Entity Framework in .NET 6 with Arthur Vickers.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast today is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. And they are hiring architects and .NET engineers who would like to become an architect. So you can go to clearmeasure.com/careers. And then finally, be sure to check out the new video show, Architect Tips. Well, my guest today on the show is Arthur Vickers. He is an engineering manager on the Entity Framework team at Microsoft. And it's a pleasure, Arthur, to have you on the show. How are you, sir?
Thank you. It's great to be here. I'm doing great. Yeah, it's been a busy few weeks. We released .NET 6, we released Entity Framework Core 6. So we're getting the feedback coming in, people using that. 100,000 downloads of EF Core 6 in the first week from NuGet. So it's got a good reception all across the board, but it's a busy time for us.
Right. Well, yeah, speaking of busy with the .NET Conf last week and the release of Visual Studio 2022 and all the stuff around it. But before we get into that, lots of people probably saw your session there, but for the people who might not have and are kind of hearing you for the first time, can you give us some highlights of your background and maybe some key points that kind of led you up to this role and this focus at Microsoft?
Yeah. So, I'm originally trained as a neuroscientist. I have a neuroscience degree from the University of Nottingham in England. And I came to the States and was doing a PhD, but I was reading programming Windows 95 in the evening. And I'm like, I want to be a programmer. Like, I've been a programmer since I was a kid. I want to do that as a job. So I got a computer science degree and then worked in various different companies doing Java, doing C++, doing stuff for oscilloscopes, doing telematics on trucks, all variety of different things. I applied for a job at Microsoft and didn't really expect to get it. And indeed, I didn't get it. But once I was in their system, I ended up with like 3 recruiters contact me and say, hey, we've got roles that you want, you might be interested in. So one of those was the Entity Framework team. And that was almost 14 years ago now, just before the very first version of Entity Framework was released. So I joined the team as a developer, resisted being a manager for many years. We went through many changes in terms of what we were doing. From being originally in the .NET framework to changing the APIs, going through EF6, going open source, and starting on EF Core. And a few years ago, somebody left the team, and I thought, okay, I'm going to acquiesce and be a manager finally. Give into those can you be a manager requests, and so here I am now. It's great. It's great to work at Microsoft. It's a great place to work. It's a very different company from when I started. It's now very open. Despite everything that's been in the news, we're very committed to open source software. It's a very welcoming and inclusive environment. So I love it here.
Nice. Well, there's a ton of developers who've just either gotten out of schooling, whether university or otherwise, and don't remember the time when there was not a very accessible object relational mapper.
Yes,
and don't remember
exactly.
a time when you had to actually think about, wait a minute, what's this term, data access layer, or how do I talk to a database? And so maybe for those, maybe we should explain why the heck Entity Framework even came on the scene, and where does it fit, and what would it be like if it wasn't there?
Yeah, so I mean, the primary problem that we're trying to solve here is what it's generally known as the impedance mismatch between writing SQL to access a relational database and writing object-oriented or functional code in your application. So, primarily in this case, we're talking writing C# or VB and then trying to access SQL. And so, traditionally what you would do is just handcraft your SQL. So you'd have to learn how to write SQL, how to write efficient queries in SQL. You would write those. It would give you back some data structure of stuff that got from the database, and you would manually take those and put them into your objects that you wanted to use in your application domain, do stuff with them, and then you'd have to go back the other way. You'd have to manually craft the SQL that take stuff out of the objects and then write it back to the database. So the whole idea of a ORM, or object relational mapper, is to avoid having to write all that stuff all the time. So instead, you just say, in some way, I have these objects in my application domain, these classes with these properties, and there's relationships with each other in this way. And I want to map them to a database which has these tables and these columns in it. And then I can just say to the object relational mapper, go to the database and give me all of the, for example, products, and include the customer, include any orders that were made in that, bring them back, populate my domain objects for me. I'll use them in my business application domain. I'll change them, I'll add them, I'll create a new order, I'll update customer information, and then tell the object relational mapper, go write that stuff back to the database. And obviously that has several advantages. I think the biggest one is just it's a lot more productive. Basically, as a programmer, you don't spend a lot of time trying to think about and writing all of this stuff that is just about accessing the database. It's just plumbing between the relational side and the object-oriented side. So it's more productive. But then also, people will always say, well, ORMs write terrible SQL. And, in the past, that was sometimes the case. But I don't think EF Core and a lot of modern ORMs write bad SQL. And in fact, when you really understand what's going on, it's very hard to have the level of knowledge to write really good SQL and also be a really good object-oriented programmer at the business level as well. And there's a lot of cases where EF is going to write better SQL than you can come up with. And sometimes, in a lot of cases, correct SQL, where you wouldn't even realize that you're not writing correct SQL because of the differences in the language. I mean, null semantics we could go into. Relational databases have 3 value nulls. Null is not equal to null. In a relational database, null is equal to nothing, right? And that's a very different concept from in a C#, where if you say is null equal to null, it'll say, yeah, they're both null, they're the same thing, right? So things as simple as that can make it hard to get it all right. So yeah, ORMs are a tool to make people productive and to give a better chance of getting correct code when you're working with the database.
Yeah, we could go into history for a long time. There's so many changes, but
yes,
Entity Framework is for .NET Framework 4.8. You've got this Entity Framework 6, and when people search for things, and can you demystify the version? So when people are searching for things, Stack Overflow, they know what the difference is and what to look for now that we're in .NET 6.
So I could go on for a long time here, so I'm going to try to keep it short, right? So the first version of EF, or EF1, was shipped as part of .NET Framework. It was in .NET Framework 3.5 Service Pack 1, in fact. And it was based on this idea of an entity data model, which was this all-encompassing idea that Microsoft had, that we would represent all our data in this common model, and applications would exchange entity data models between themselves. And that's how applications would communicate. And EF was I wouldn't say it's an afterthought, but it wasn't really built as an ORM, as I've just described. It was built as a way of accessing entity data model, and that happened to include reading and writing from a database. So when I joined the team, it was solid product in terms of a lot of the infrastructure, but the user API was not good. It was very hard to use. It had features that people didn't want. So we spent a number of years making that better, adding the DB context API. The original version of Anti-Framework, people might not know this, had a thing called object context, which was a very different API from the DB context that people are used to these days. So we improved that a lot, and we took it open source. And the version that was open source and is still out there on GitHub now is EF6. And at that point, this was about 5-6 years ago, maybe. This was when cloud was becoming, we really need to make things work in the cloud. We need something that's more lightweight, that we can run at higher density. We want something also that can run on devices. If you've seen Steve Sanderson's talk at .NET Conf, if you haven't, go see it. But it uses EF in the Blazor with SQL Lite, all in WebAssembly. Awesome, right? So we wanted stuff that could do that kind of thing. And at that point, it was like, okay, this thing that's based on EDM it's really holding us back. It's this massive architecture based on EDM, and none of our customers really use it. It didn't take off like Microsoft wanted EDM to take off. It's still used in OData, so people using OData still see EDM, but other than that, that's really the only place it now lives. And so that's how EF Core got born. It was like, okay, let's take the good stuff out of EF, but let's basically re-implement it. And it's funny because re-implementing is almost always the wrong thing to do. But in this case, I think it worked out pretty well. So yeah, re-implement it in a lightweight manner, in an extensible manner, in a way that isn't tied directly to SQL Server. It's not tightly coupled to SQL Server. So, we have great providers for Postgres, for MySQL, lots of SQL Lite, obviously. And it's lightweight. It runs in the cloud. It runs at higher density. It's much higher performing, and it's suitable for running on devices or in Blazor apps. And so that's how basically we ended up with EF Core, and now we're up to EF Core 6.0. So we've kind of caught up in version numbers to EF6, and the next version is we're just going to refer to it as EF7. Officially, it's still EF Core 7.0, and we won't change the namespaces or anything like that. But now that we're past those conflicting numbers, we can just say EF7 next version. So that's pretty cool.
Okay. So there's a lot of things that are new for EF Core 6. You presented at .NET Conf. There's the maybe we should just let people know, we can't go deep into each one of them, but just the newest things where if they've used it before, they really need to look into these new features.
Yeah, so probably the biggest thing in EF Core 6 is a thing called temporal tables. This is a SQL Server feature that lets you automatically keep a history of every change you make to a table. And so EF Core 6 now supports creating and managing temporal tables with migrations, and also running queries against that historical data. So that's a big one. We have compiled models. So when EF Core starts, it builds a model that represents all of your entities and their relationships between each other. And for most people, that actually is fine. But if you have thousands of entities, then it can take a while to build that model. So we now have a way to pre-compile that, and it can basically give you more than 10 times improved startup performance for a big model if you use compiled models. Also on the perf front, we've done a lot of work for queries. The Tech Empower Fortunes query, which is a benchmark that's kind of an industry standard, not managed by Microsoft. We're now much faster on that. And in fact, some people may have heard of Dapper, which is a great micro ORM for .NET, which we love. If you were using that only for perf, then EF Core is basically only about 2% slower than Dapper now on the Tech Empower Fortunes. So we've really increased the performance of that greatly. So I think those are some of the biggest new features. And then we closed about over 500 issues as fixed in EF Core 6.0. So there's literally hundreds of other enhancements, smaller things, improvements that may or may not be important to you, but are often important for the people that need them. They're like, sure. That's why I really need
right.
it. So yeah, go check some of those out too. And then a lot of bug fixes. We're always trying to keep the quality high, so we tend to try and fix everything we can.
Okay. You mentioned Dapper, and you're right. There's some people that have said, oh, for performance reasons, I'm using Dapper, but there's a lot of other developers who are also using Dapper for backwards compatibility. They moved to .NET 5 or .NET Core, .NET 5, and then realized, wait a minute, I'm accessing an OLEDB driver, OLEDB data source. Well, I can do that with Dapper on .NET Core and .NET 5, but I can't. Is that just the way it is, or are there thoughts about changing that?
So it's a different level of abstraction. So Entity Framework is very very much aware of the provider it is talking to and the database it is talking to, because it basically has to generate SQL. I mean, there's a lot of other reasons, but let's focus on it has to generate SQL. So it needs to know what you're running against and what SQL needs to generate. So OLEDB is, it's fine, but it doesn't. If you're connecting to an IBM data source with OLEDB, you need entirely different SQL than if you're, connecting to a SQL Server data source. So that's really not a problem if you're at the Dapper level of abstraction, because you're writing the SQL anyway, and so you just write what you want. But if you're at EF level, you need what we call a provider, which is basically a plugin to Entity Framework Core, which understands how to write SQL for that particular database. And so while we have a lot of those available, there's a lot in the community. I mentioned some already, and then there's commercial ones from Oracle, and IBM has one for BB2 and things like that. It's not feasible for us to just support everything that you could connect to through, ODBC or OLEDB or one of these, kind of abstract APIs. Whereas for Dapper, that's easier because it's basically pushing the work on you to, write the right SQL. So it's the right tool for the right job. Like I said, we love Dapper. We love Nick Craver and Mark Gravel, who worked there. They were on our EF Core community stand-up a while ago talking about Dapper. And it's a great tool, and it's great for .NET developers to have options to use the ones that they want. But they do different things, and even on Stack Overflow, which is what, where Dapper was developed, they use EF Core for basically doing database updates, and they use Dapper for doing, their high-performing queries. And that's a great combination to use both. So yeah, use whatever works for you, but it's not always going to be EF Core, and that's fine.
Okay. You also mentioned the temporal table support, and SQL Server now has just pretty much push button support for temporal tables. Yes. There's listeners out there who don't know what that means.
Okay. Yes, I can go into that. Yes. So basically what happens in SQL Server temporal tables, or system version tables is another way of referring to it. I think the SQL Server documentation often says system version tables. And the idea here is that when you create a table, or when SQL Server creates a table on your behalf, it will automatically in the background create another table next to it called the history table. And this basically has all of the same columns that your main table has. It removes the constraints on them, but it's the same columns. And then whenever you do an update or a delete of a row in your main table, before that happens, SQL Server will automatically take a snapshot of the current state of the row and put that into the history table. So the result is that the history table contains this, basically, as you would say, a history of everything that happened in the main table, and it includes timestamps, so you can know, from this time until that time, the main table was in this state. So the obvious use for this is auditing, right? You can go look back and see, okay, this is what actually changed in the table. It's also very useful if something goes wrong, somebody deletes something that they didn't want to delete. Now you've got it back there. You can go and query in that history table and recover the data from there. It's useful for diagnostics. Okay, what went wrong here? We don't know what went wrong. Somehow the table got into the state, but we don't know how that happened. So it's a very cool way of basically automatically keeping this track of everything that happened. And with EF Core 6, we allow you to say in the model builder, this entity type is mapped to a table that I want you to make it a temporal table, and then this history table will get created for you and everything. And then when we run queries, when using LINQ, the query language in C#, you can say temporal as of or temporal between, And we will, instead of going just to the main table, we'll go to that history table and automatically pull back all of the rows and create entity snapshots of those as they were at various times in the past. So it gives you good access to all of this auditing, historical, diagnostic data as you want to use it.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
One of the scenarios that excites me that I think would affect a lot of people is prepping for data warehousing. Whereas without it being automatic, if you want to develop a data warehouse, you basically have to realize, I guess I'm going to start recording as of this time and this date forward because I haven't been capturing those changes. Whereas with existing application, new application, we can just enable it now, even before building any kind of data warehousing, knowing that when we do bring those OLAP data sources, we will have the raw data to transform into them.
Yeah, and I think with the way modern economics are in terms of storage, storage is cheap now, and there's very little overhead with this because it's built into SQL Server, Azure SQL. So basically, it's at the level where, yes, if you do an update or a delete of a row, you have a tiny bit of extra overhead because it makes a snapshot into the history table, but it's negligible for most people. And it's not like you've had to build this into the application. You're not doing multiple round trips to the database in order to do it. So it's very easy to just say, right, I'm just going to switch this on and capture this data. I don't even know what I'm going to use the data for, right? Mm-hmm. But I'm just going to capture it all because, I've got the space to keep it. And, and you can periodically do things like clear out the history table and move it to another place so that, you can keep backups of it like that. And it's great. Yeah.
Another thing that you mentioned performance. And I think on the .NET Conf video, it was just massive number, like really good performance. Now, it used to be that indexing was a big topic of conversation, but I just happened to notice that I haven't heard it be talked about so much anymore. Have you seen the same thing, or why is that? What do developers need to do with indexing?
Indexing is very important still. So performance is one of those things where it really depends what you're doing. But there are cases where you definitely need to, profile your database and look at the query plans that it's producing and figure out, I need an index on that thing. Now, with Entity Framework, we try to create indexes for you in reasonable places automatically. So in a lot of cases, you're just going to get the index there without thinking about it. But there's also cases where you're doing a particular query on a particular string column and it's got a particular collation, and so you need to make sure that you create that index properly. So that is still very important to understand those things. But as always, it's do it on a case by case basis. Like figure out where you're slow, and then figure out that you need to put an index on that thing. It's not a case where if you try and do all your perf stuff up front, premature optimization, I think we call it, you'll end up just spending so much time trying to make things fast that aren't really a bottleneck in your application anyway. But where you do have bottlenecks, understanding what's happening in the databases and in the database and putting the appropriate index in the appropriate place, that is still very important.
Okay. I'd like to also ask you about the current state of schema migrations in Entity Framework. Yes. And there's been a history, and even I've interviewed some other product teams at Microsoft who currently to this day are using open source projects like DBUp put out by the Octopus Deploy Group or Roundhouse or AliSQL, and then there's the DAC pack, and then Entity Framework has them built in. What's the What's the state of the art in that space now with .NET 6?
So it's a little bit again, use the right tool for the right job. EF core migrations are a very good way of managing your database if you are using the code as your source of truth. If you have the ability and understanding of how to deploy those migrations correctly to the database. But one of the things that's always been challenging is that latter step. How do I actually get the migrations that I've created and update my database with those, so update the schema with those? Traditionally, the best way to do that has been to create a script and then apply the script. In EF Core 6, we've added a new feature called bundles, migrations bundles, where you create we basically package up for you all of the migrations for your database into an executable. That executable can be entirely self-contained, so you don't need to install anything on the machine that it's running on in order to run it. And then you point it at your database and say, okay, execute that. So this is similar to some of the things Octopus Deploy, DB Up, and tools like that do. It basically, makes it easier. I've seen a lot of people ask the question, well, what's the advantage over just doing scripts? And really, if you understand how to do scripts and how to deploy those and how to find a tool and connect to the database and run those scripts, there is really no advantage, right? Like, that's all fine. That works great. But that's challenging for a lot of people. And so having this bundle, which makes it easy to package this all up and then execute it, that's the advantage there. On the other side of the fence, I have a database and, I'm got a DBA managing it, or it's a legacy database. I'm not creating it with migrations, and in that case, DAC packs can be a great way to manage those. And we have reverse engineering tools in EF Core that will take a database and create a model from those. And so you don't need to use migrations. And again, that's fine, and that's like a fully supported way of using EF Core. It really depends on where you're coming from in your environment and how you're deploying and where you're running your database and all those things. But, just like with everything, we aim to provide solutions for whichever of those you want. We're not trying to force people into using migrations or telling people you should use migrations. It's like way better than DAC packs or whatever. It's like there's different ways of approaching all these things, and we want to make them all a great experience. Yeah.
Okay. Now, if there's, I don't know, a small handful of tables in the database that are not mapped through into Entity Framework to objects, does that preclude any framework migrations approach from being used, or is that still compatible?
Yeah. So there's ways to say, exclude this entity from my migration because it's being managed in some other way. There's ways to say, okay, reverse engineer my database and only bring in these tables because I actually don't want those in my database. There's a concept, kind of DDD type concept called bounded contexts, where you split your database into multiple kind of domains which handle different parts of your application logic. And so you can create, for example, a DB context for one. It's kind of interesting that bounded context and DB context use the same term here because they're not really the same, but it maps very nicely to, I have one DB context for one part and I have another DB context for another part, and I can have foreign keys that go across those two things that I can kind of set manually where I really need to go across, and EF Core manages all that just fine. It's pretty flexible in terms of how your database is laid out and which parts of that you choose to map into which context.
Okay. Now, looking forward, you mentioned one of Steve Sanderson's demo about a Blazor WebAssembly application using SQL Lite and Entity Framework running in a browser. Now, tell me if this is overstepping the scenarios that are actually supported, but does that mean, and you can see I'm getting kind of excited here, does that actually mean that if I need a disconnected Blazor WebAssembly application, I can, on the server, read in using Entity Framework some objects, and then I can immediately switch over to WebAssembly and just tell Entity Framework through SQLite, hey, save these things, and then the internet cuts out, and then I use the same data access code just to get and manage that data while I'm in a disconnected state?
So mostly, yeah, I would say we're getting there. So if you watch Steve's demo, one of the things he does is, basically, so he starts up, connected to the internet, uses EF to go query a bunch of stuff from the server on the cloud and bring it back and store it in the local SQL Lite database that's just running inside WebAssembly. At that point, in Steve's demo, he shows how you can now run in a disconnected state. The internet's gone, but I can still access all that data that's in my SQL Lite database. And it's perfectly, great experience. You've got all the queries. You can filter. I think he had 100,000 records in there, and it's fast and it works really well. The one thing you do have to be aware of is that we won't automatically queue updates for when the internet comes back. So you do have to write some code that says, okay, these things I need to update, and then, right, I've got the internet, I can connect to the cloud, so now go update them. So it's not like a fully kind of automatic, as soon as the internet comes back, it's going to resync up to the cloud. That's a very difficult problem to do in a general sense. It's one of those things where if you have a constrained scenario, so what kind of updates you're going to do and how you're going to do them, it can be quite easy to write that code. But if you just say, I want it to handle any kind of update and I want you to do it automatically, it becomes very difficult. So It's kind of one of those things where we try to provide the tools for you to be able to do those things easily, but we don't want to say, here's a magic box that will just do it all for you, because then that magic box just becomes very complicated and often quite buggy and difficult to use because of all the complexity. We had something called self-tracking entities in a very early version of Entity Framework, and it suffered from all that. It tried to just handle every case, and it was not a great way of doing that. So it's almost to what you said, but there's still a little bit of manual intervention to sync back up with the cloud once you get back connected online.
Well, there's the disconnected example, but I'm also thinking of caching scenarios where you're running in the browser and you need some common customer records, and without a data layer that is effectively the same technology that it is on the server, you're effectively writing a second method for reading and accessing data just to do some caching to avoid going back over the wire to get data.
I think that's one of the things that's really exciting about seeing SQL Lite in WebAssembly accessed by EF Core, because this is the full kind of technology that you're used to using for querying your databases. You've got the full linked query language, you've got the full chain tracking capabilities, you've got everything there, and it's all the APIs that you're used to, and everything is basically the same. I think Jeremy Lickness in one of his demos has shown connecting different backends and how you can use basically the same APIs. Now, I will say here, there are differences in databases, right? So SQL Lite doesn't behave always the same as SQL Azure, and you need to be aware of those things. But there's still the fact that you have a common interface and a common way, a common set of tools, if you like, a common set of abstractions for accessing that thing, and you can use it totally offline in the browser against a SQL Lite database. It's very powerful, and like you said, instead of now having to write your own kind of offline store, storing stuff in objects and then trying to figure out how to just forget all that. You just use EF Core and SQL Lite, and you've got the full capabilities. It's very powerful. It's very exciting.
Yeah. Now, looking forward, Entity Framework 6 is out, .NET 6, Visual Studio 2022. What are y'all working on now? What's next?
Right. So, I mean, we're basically starting the planning. I say we're starting the planning. We're pretty much done with the planning for EF Core 7.0, also going to be called just EF7. It's being reviewed internally, but as always, as we've done for many years, that's going to go live. It's going to be there for people to look at and to critique. there's a lot of different factors that go into deciding what we do in the next release. We have strategic concerns coming from inside Microsoft. We have various things where we need to, make the ecosystem and the platform better. So one of those, for example, is linking for things like the WebAssembly. We want to make EF Core much more linkable friendly, which helps with application download size in Blazor, also helps with AOTing. I think Stephen also showed how, when you ahead of time compile these things, it's so much faster. So there are things like that. And then a lot of it comes from the features that people have voted for on GitHub. There's the little thumbs up on every issue in GitHub, and we look at those. Temporal tables was the most requested feature that we had. We as we do features, they fall off that list because they get closed, right? So and then other things bubble up, and for the planning for EF Core 6, temporal tables was the most requested, and it got done. And there's a lot of those highly requested features that we're trying to put into EF7. But if you haven't voted for the features that you want, then go vote, because it really does influence what we do. And then, we have a yearly cadence now. So November next year, EF7 will be out, .NET 7 will be out. It's easy for you, to plan for that, because instead of it just being, oh, we're not sure when the next release is going to be or what it is, this is all a very regular cadence that we have here. Yeah.
Awesome. And for people to go vote on those issues, github.com/ is it in the main .NET or is it?
.NET/EF Core, yes.
Yep. Is it EF Core? All right, we'll include that in the show notes. All right,
yeah,
great.
That'd be great.
And we'll also include the link to your session at the .NET Conf last week. And as well, how can people find you or keep up with what you're doing?
AJC Vickers on Twitter. So that's me on Twitter. AJC Vickers on GitHub. So that's me on GitHub. I'm lucky in a sense. I never thought I was lucky as a child, but my parents gave me two middle names, so I actually have two middle initials. So when I try and use a username, A Vickers is usually taken, but AJC Vickers is rarely taken. So I've managed to get that in a lot of places. So yeah, that's follow me on Twitter. Look me up on GitHub. As always, if you're having an issue, contact us on GitHub. We're very active as a team on GitHub. We try to be very responsive to questions that people have. If you want to send a pull request, I think we've taken 10 community contributions in the last couple of weeks already to go into EF7. So if there's something you want to work on, then get in touch on GitHub and go for it, because we love that stuff.
Awesome. Fantastic. Well, Arthur, hey, thanks so much for coming on the show and telling us all about Entity Framework Core 6. This has been great.
It's been a pleasure. Thanks very much for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.